Hello guys, welcome back to the channel and welcome back to an awesome unboxing of what is in this box. Now obviously if you read the title, you know what's in this box. Let's talk a little bit for a minute about what is actually in this box. So I know as a turbine flyer, many of us are very hesitant to change. Now I've been watching Swiwin for quite a few years now, thinking about trying out one of their turbines, and the day's finally come. All right, so Swiwin Turbines reached out to me and we had some discussions back and forth over the past few weeks. And ultimately, what happened was this turbine showed up just tonight, and now I've got a turbine in my hands that I get to play with, run, and test out. We're also going to be putting it in the Aviation Design Diamond, assuming that I'm happy with it. And we're going to be flying it for the season to check things out. So I'm really excited to open up this box. Now this is the brand new 220 model. We'll get into more details as we go through this video, but it's going to be a really exciting unboxing of this turbine. Now one of the other things that I'm excited for, guys, is in anticipation of this turbine showing up, I also built a test thrust stand. So I built this over the past couple days, and basically we've got a way to measure thrust on the turbines now, which is very, very exciting. So without further ado, we're going to open up this box and we're going to talk a little bit more about Swiwin as a company, and we're also going to cover this particular turbine, which has some very, very exciting features on it. We're going to do all that before we run the turbine. We'll cover all the ins and outs of the actual stuff in the box. Then we'll get that turbine installed on the test stand and we'll do some testing with it, some run-ups with it, and it's going to be a great video. So thanks for tuning in, guys. If this is your first time here, hit that subscribe button down below. Hit the bell when you do hit that subscribe button, and give the video a thumbs up. All right, guys, let's open this up and see what's inside. Now, I haven't opened this thing yet. This is a true unboxing, and let's go. So this was shipped to me by DHL, and the benefit of DHL is, at least here in Canada, this took under a week to show up from China. So very, very quick shipping, and I'm impressed. All right, so the standard box, as we know, and what do we got in here? So we got some fuel tubing. So we have some 6 mil and some 4 millimeter Festo tubing. All right, so let's go through all the accessory pieces and then we'll look at the turbine last. So we've got our standard Pisco on-off valve. We've got the brushless fuel pump. One of the features of Swiwin turbines is the fuel pumps are brushless. All right, we've got a fuel filter. The ECU is there. We have the standard cable set. Again, we'll take apart all these things and take a look at them. And we've got the data terminal. Nice and small. I thought this was going to be, based on the pictures and stuff that I've seen, I thought this was going to be a lot bigger, but that's a really, really nice size. And it's a nice size that can also stay in the model too. All right, so that is everything in the box. There's the turbine. We're going to weigh these things as well. All right, so we'll unpackage these pieces one at a time and take a nice close look at them. Okay, so data terminal, pretty standard unit. It's all aluminum. We've got 4 buttons on it and they're nice and solid. There is a screen protector on there as well too, and nice little piece. Okay, so the ECU, again, same thing, all aluminum. Everything's labeled nice and clearly. This is the V3 ECU. It says it right on the bottom corner there. But clearly labeled. We've got telemetry, DBus, GSU, PPM, which is your signal to your receiver. We've got 3S LiPo battery. That's one of the other things about these turbines is they can be run on a 3S LiPo battery. Cable going to engine. Now again, this is a bus system, so there's just one single cable going to the engine, and then our pump as well too. All right, filter. The fitting we're not going to open up because that's just a standard fitting, a normal fitting. Filter, I'm always interested in the filters just because some are better than others. So now let's take a look at the fuel pump here. Alrighty, so fuel pump, that's it. Brushless fuel pump, really, really small. Has a built-in mount as well too, which is nice. And now this fuel pump is, I think, the same fuel pump they use for all the turbines, but the way you set this fuel pump up is different depending on the turbine. So on the larger turbines, you've got essentially 2 inputs and 2 outputs. So there's the 6 mil Festo line input and the 4 mil output. Now, if you have any questions, if you're watching this and you've got a smaller Swiwin turbine, if you look in the manual, you can see that some of them are, you go in the input, out the output, in the input, out the output. So I think what it does is the pump essentially chews up any air bubbles that make it to the pump and affect the turbine less, is the theory behind it. So anyways, that's the fuel pump. Nice and small, great size on that thing. And I know this may not be a big deal to some, but these cables are nice and flexible. It's like a silicone sheathing on this thing. It's not like that really stiff wire. And then we've got the MR30 connectors as well. So we've got our bus cable going to the turbine. Okay, and I'll give you a length on that. Okay, so this particular cable that came with this turbine is 29 inches in length. And we've got our standard battery cable, so a XT60 end on this end, on the actual battery plug-in, and then the small plug-in that goes right into the ECU. And this is probably very similar size. Yep, same size as the turbine bus cable. And then we've got our standard servo cable. All right, guys, last thing we're going to take a look at is the turbine itself. All righty, there she is. Okay, so overall, I think very, very similar size to the 210, 220, 235 class turbines. I'll put all the data in the description below. So we've got the model here. So it's an SW220B 061 serial number. So nice solid mount on this thing. No flex in the mount hardly at all. Now, one of the things with the early 220s, and you may still see this floating around on the internet, is that there was no FOD screen. So mine was shipped with a FOD screen. I didn't request it or anything, but that is what it came with. So we've got our single fuel input there. We've got our bus input there. A little opening section, I'm assuming for ventilation. So one of the other key points with the Swiwin turbines is brushless starter motor as well too. So that's all normal. And the FOD screen on this is really, really cool how it's integrated. So this is an Outrunner brushless motor, and then the FOD screen, the mounting bracket goes around it, and it's mounted so it doesn't affect the starter motor. Here's a shot of the exhaust cone. Couple important things with this turbine: all the injector tubes, the injector needles, the combustion chamber, they're all Inconel, so that's a standard with all the Swiwin turbines. One other thing that I'm doing some reading on is when you raise the throttle stick at any time, it goes into cool down mode. So that's at any time before the turbine's running, after the turbine's running, which is kind of nice. There was some turbines that used to do that as well, and it was kind of a nice safety feature, so you could enter the cool down mode whenever you wanted to. Now, one of the important things that I liked when I read about this was the actual size of the compressor. So I'll throw some pictures up here that I believe I found on the internet. And this turbine is designed around a larger size compressor wheel. So what does that really mean? It means it's not going to be starving for air to run this thing. And you've got a larger size turbine running at a lower RPM versus a smaller turbine running at a higher RPM, which seems to be a fairly normal thing to do nowadays. But this is the opposite, and it's kind of a nice thing to see because it should mean that your turbine should have more life out of it. But of course, these are all things that I'm hoping to find out over the next season of running this. I just want to throw a quick shout out to Swiwin. Thank you guys for sending me this turbine. Thank you for getting it to me in a quick manner. And thank you for allowing me to test run this engine, play around with it, fly it. I do really appreciate it, and thank you for your support. All right, guys, let's look at the weight of this thing and see what she comes in at. All right, so scale is zeroed out. And so just the turbine itself weighs exactly 1,800 grams. That's with nothing on it. Obviously, the solenoid valves are inside the turbine. We throw the ECU on there. We're up to 1842. Fuel pump, 1955. And we'll just throw all the cables on there as well. So all the cables and the fuel filter, we're at 2,019 grams. And then with the data terminal, which of course you don't need to leave in the plane, we're at 2,070 grams. So if we go 2,070, right, divided by 454, for you imperial folk, that works out to 4.56 pounds total. There we go. 4.56 pounds for everything in the box. All right, guys, so I kind of got everything roughly set up. We're not ready to run this yet, but we're close. So I've just powered on the system, and this is the screen that comes up first. So you get to select your language. So we've got English, a bunch of maybe Chinese, Japanese, not quite sure, and then Spanish there as well too. So you just use your plus and minus buttons, and I'm assuming you hit OK. There we go. So language has been selected. There's no battery hooked up to this right now, which is why it says error engine offline. I just wanted to make sure I showed you guys that first step. All right, guys, so I've got something kind of special here planned for this turbine test. This is something that obviously we haven't done on any of the turbine tests previously. So number one, we've got the thrust stand, which is cool. But we're also going to do a consumption test just to check the accuracy of the manufacturer's recommendations. Now, Swiwin provides a recommendation of fuel consumption at 90% throttle, not full throttle. So regardless, sometimes there's some variation in fuel consumption, and that's why we want to check that. So that's going to be a little bit later in this video, but let's go over some of the features of the ECU, the data terminal that are kind of special with this turbine. Okay, so here's our rig set up. So we've got two fuel inputs, and reason for that is we've got the primary tank, and then we've got our consumption tank. So we're going to run this until it's completely empty, and then we're going to time it. All right, so we definitely need bent screwdriver's help as we go through this ECU and data terminal. So we'll just go over all the primary screen when you turn it on. So when you turn it on, this is the screen you see. The beeping you hear is the communication between the turbine and the ECU. So obviously you've got some basic things, your RPM, your current temperature. So the amps is the current amperage draw in the system. So when this is starting and you've got the starter motor spinning, you've got the fuel pump spinning, you've got the glow plug working, you'll see this to be probably 5-6 amps, and then it'll drop as the turbine starts. So capacity, that is the battery capacity and how much you've used of your turbine battery. So that's kind of a cool feature that's right on the main screen. Power voltage, so we're running this off a 3-cell LiPo, so we're at 12.5 volts right now. And then we've got your receiver voltage, which currently is 8.1 volts. Time, that is, I believe, the time on the current run. Now, this is the model, so Swiwin 220B for brushless. When you accelerate, it's going to tell you from complete idle to full acceleration your time right there. And that's always on the home screen, so I think that's kind of neat. Obviously the current state, the RPM, so where it is in the RPM, temperature, so low to 1,000 degrees. Pump, this is an interesting one, so it's got 6,000. So what that currently means is the max pump power is set to 6.0 volts. And your RC is where your throttle stick is. Now you'll see this pump power change if it needs to. So if we're throttling up and the system needs more power, you'll see this automatically change, but you do still want to add 20% to your max. So let's say we do a full speed run on this thing and it bumps us up to 6.5. We want to add 20% to that number, and you can go in here and change the max pump voltage. So that's a shot of the home screen. Now if we push the C button, you'll see that you can get a big display. So just easier to read. Okay, and then now we're back to the regular one. So you've got OK, C, which is like clear, plus and minus. So if you hit the OK button, this brings you into all of the information and the settings and everything. Now the reason I'm going through all this stuff, guys, is this is new to me, and if you're a user of basically any other turbine that's not Swiwin or something similar, this is going to be different to you as well too. So if you've used a Zukoi FADEC or ECU, if you want to call it that, this is going to be a bit of a different setup, and that's why I want to go through this, is because it's different and it's kind of neat to see all the different features and adjustments. Okay, so I'll try and run through this fairly quickly. But I'll just want to give you an idea of what's going on here. So we've got our total time, that's run time on the turbine, cycles, stop RPM, stop temperature, max RPM. So that's probably the last run. So anyways, if we go into startup, so we hit the OK button, this gives you all your startup parameters. So I'm not going to go through these, but there's a shot of everything that you can adjust. And there are some things that are good to adjust in there. Anyways, so that's the startup menu. Push the C button to go back. The running menu, so we've got our RPM accel and decel. Now this is a little bit different than other turbines. The larger this number is, the faster those things are. So if we bring this up to 50, it's going to accel a lot quicker. Okay, max RPM 115,000, idle RPM 38, but there's all the information there. Restart, this is where you'd adjust whether you restart or not. So right now the restart's turned on, and restart glow plug. Now sometimes the restart glow plug, this needs to be higher, and also the startup glow plug might need to be a little bit higher than 5.4, but we'll adjust those things as we need to. Okay, let's go back to the running menu. So pump limit. So right now the pump limit is at 10 volts. Doesn't need to be at 10 volts, but what we want to do is run the system, find out what the max is needed in the system, and then we'll adjust the pump limit afterwards. Okay, so study RC. This is a different one that's different than any other turbine that I've ever used. Okay, so what you do is the max. Okay, so you'd hit OK for max, and the max is trim up, throttle up. And it tells you your current number right there. So if I adjust my throttle stick up, you'll see the number increase. Okay, I've already learned this to the turbine, to my radio, but then you'd hit OK. And you go back, and then you adjust your idle. So that is throttle stick, or trim up, throttle stick down. And then minimum is off, so throttle stick down, trim down. So that's how you adjust that. You've got your fail-safe time, some bus and telemetry stuff there. So that is that menu. Starter is pretty straightforward. So this is just some starter stuff that you can adjust. So we could turn that beep off actually if we wanted to. Cooling, this is going to be your cooling RPM. Other. So this is where you clear the battery that's used. So let's clear this. There we go, because we got a fresh battery on there. You can adjust the temperature units, and pump types. So these ECUs, they can be used with a brushless pump or a regular DC pump. And then you've got all your versions of your programs. Okay, we got our standard test menu. Okay, so we can test our pump. I won't do that because we've got to redo a bit of that stuff, but basically you hold down the button and your pump will start. Okay, so then you have your other test things. So another interesting thing about this is I'm going to test the fuel valve and just listen. You can hear it clicking. Very, very distinct. I know some other turbines I've used, not quite as distinct as that. And then we've got all of our other test things as well there. Okay, last two things, data chart. So this shows you your runs. Okay, so you can look at the runs, you can go through the entire run and everything and look at the history there. And then of course you've got the language. So that's basically the ECU setup. So it's completely new to me, but it's very, very intuitive. I like it. It's very simple to navigate it. And the adjustable things on there, the manual is very, very straightforward. Now, I'll tell you right now, one of the questions that for me came up with this turbine years ago when I was looking into it originally was, where do you get them serviced? So when Swiwin first came out with turbines, they've been around for quite a while right now. I think 5 to 7 years. I know somebody can correct me, but they've been around for quite a while. Their CNC processes and machines and everything are amazing from the research that I've done. But if you were in North America, you used to have to send the turbines back to China to get serviced. Now, as of recording this video, there's actually 2 service centers down in the US, and so that's positive. Basically, we have options on where we can send these things for service. So service is a complete non-issue. Okay, guys, so I'm going to get this thing ready to run. I'm going to get it mounted by my garage door, and we will fire this thing up. All right, guys, this is test run number 1 of the Swiwin turbine. I haven't adjusted any of the parameters, so this is just a raw startup right from the factory, and we'll see how it goes. Now keep in mind, it's about minus 24 degrees Celsius outside right now, which is minus 10 degrees Fahrenheit. Okay, so a couple takeaways from that. It started really well. I'm impressed with how it started. It hung a little bit on the fuel ramp. Now that's my fault. I forgot to take my vent plug out of my tank, so it was restricted sucking fuel. I'm not going to make any changes to that, I don't think, but I am going to possibly adjust the setting to increase the speed from idle to full throttle. Now, if you saw in the screen, pay attention to that screen, I'll throw a screenshot in here, it was 5 seconds on those last throttle ups. So we can get that down to about 4. 4 is a comfortable number, which is insanely fast. From a true idle to full throttle in 4 seconds is fast. I've seen some videos from Thomas at Swiwin where he's had these turbines running at 2 seconds from full idle to full throttle, but he says 4 seconds is kind of the comfortable number. So I'm going to play with that a little bit. I'll show you guys how to adjust that stuff as well. All right, guys, for run number 2, I'm going to leave all the startup parameters the same. Reason for that is as I mentioned, I had that vent closed. So I'm going to leave that the same. Just so you're aware, I am running kerosene on these tests, and we are using Kingtech Oil. Okay, so I'm going to adjust the ramp, though. So my Excel, we're going to switch that to 30. And we're going to put the decel, to 30 as well, just to see how different that is. So just remember that our first run, our acceleration time was 5 seconds. We'll see how that adjusts and changes the acceleration. We're also going to put the pump limit. We're going to adjust that as well. So the current pump is 5.9, and if we add 20% on 5.9, so we'll just put it to basically 6.9 volts is what we'll put it to. Actually, we'll put it right to 7 volts, so that should be good. Okay, guys, so for this test, run number 2, we've got some extra fuel added here. So we've got about 2 liters of fuel. And then what we also have is we've got exactly 1 liter of fuel. So what this test is going to look like is we're going to start the turbine. We're going to play with the acceleration a little bit just to see how it works. And then what's going to happen is I've got my lovely helper here who hates being on camera. Katie's going to give me a hand. So we've got the primary fuel coming here. We've got the 1 liter tank coming here. So what's going to happen, and this is what I need her help with, is we are going to switch over the fuel supply, start a timer on an iPhone, which will be sitting right down in this area, and we're going to go to full throttle on the radio, and we're going to time exactly how long it takes for the turbine to go through 1 liter of fuel. So then what we'll have is some consumption numbers calculated for each minute of runtime at full throttle. When that runs out of fuel, that will also test the restart of the turbine, because when that runs out of fuel, turbine shuts down, we're going to reopen the primary fuel system and we'll continue sucking from the primary fuel system. So there's a lot going on in this test, but it's going to give us some clear views on consumption numbers, the restart, and we'll get to see some thrust figures, and we'll see how the adjustments change the acceleration time. So going to be a good second run on this thing, and looking forward to it. All right, guys, you'll notice that we're almost at 38,000 idle, and we've got a idle thrust of about 2.5, 2.6 pounds. Now we're throttling up to full thrust, and the full thrust time was 3.8 seconds, and we're just under 50 pounds. And we are back down to idle. Now we're going to do another thrust or acceleration check. So if you watch the screen on the data terminal, you'll see 3.7 seconds is our acceleration check from complete idle to full throttle. This, of course, being adjustable, and full throttle being 115,000 RPM. All right, now we are doing the fuel consumption test. So the fuel has been switched over, the timer has been started, and full throttle has been engaged on the turbine. And what we're doing here is we're letting it run for as long as it takes to go through exactly 1 liter of fuel. Now what this does is it allows us to come up with a consumption of fuel per minute. So what you'll see here is we're approaching the 1 minute and 15 second mark, and that's how long that 1 liter of fuel lasts. Now, as I mentioned previously in the beginning part of this video, the restart glow plug power was not turned up high enough, so it was in the low 5 volts, and the turbine was not able to restart properly, and that's why you see all the smoke pouring out the back. All right, guys, that was pretty crazy. Now, I kind of figured that would not work out with the restart. Now, the reason I figured that is because the glow plug temperature, you've got 2 numbers. So you've got glow plug normal start, and you've got glow plug on restart. Now, the glow plug on restart needs to be a little bit hotter than the regular start. So I think the regular start is 5.6, and that's actually low, but it still worked out good. And then the glow plug power on the restart should be between 6 and 6.8, I believe. And we are at 5.6. So you could see all that smoke billowing out. So what was happening was, number one, it's minus 22 degrees Celsius outside, minus 9 degrees Fahrenheit. And the pump was spraying fuel back in, and it wasn't igniting. So we also had a ton of air in the system as well too. Because that switchover, we sucked a bunch of air in from the 1 liter tank, and then we switched over tanks, and there was a whole bunch of air stuck in there. So what I'm going to do is I sacrificed my GoPro for the tail cone shots. It's completely covered in fuel and oil, but I think I got it all off. I'm going to do another run-up of this turbine, and I'm just going to do a fuel restriction on it. But I am going to raise that glow plug power on restart as well. I'm probably going to bump it up to about 6.4, somewhere in that range. And we'll do another run up and see how this thing's running. Now, the power output on this thing, I think it was like 49 pounds. We're 3,000 feet above sea level where I'm at. So generally, we get about a 10 to 15% reduction in our turbines. And this thing is actually giving us more power than what is listed. So that 1 liter of fuel lasted us 1 minute and 16 seconds, which is, I don't know the numbers per minute, but that's, I don't know. Anyways, I'll figure that out and throw that in the video. So generally a 220 Newton turbine, which is 22 kilograms, puts out 48.4 pounds of thrust. And we would normally see, let's say, a 15% decrease. So minus 15%. So we would normally see about 42 pounds of thrust from that kind of category of turbine. We'll say 42 to 44 pounds of thrust. That's really impressive. And it's going to be interesting to see how it works in the summertime when our temperature is a lot higher. But we could also turn the RPM of that turbine down and still get reasonable results with it. So maybe what I'll do on this run as well too is I'm going to turn that down to 110,000 as the max, and we will see how much thrust output we get at 110,000 RPM and compare that to the 115 that it's set to. All right, guys, this is test run number 3. The goal for this is we've got 110,000 RPM as the max, so we're going to check the thrust at 110,000 RPM, and we are also going to check the restart. The glow plug on the restart has been bumped up to 6.4. So you'll notice here as I throttle up, the acceleration is 3.5 seconds and our max RPM is set to 110,000. So what's happening is the pump is auto-calibrating, but the total output at 110,000 RPM is about 45.5 pounds of thrust. Now we're going to introduce our fuel restriction, and the turbine shuts down and goes into restart mode. So during this last section of the test, I'm just going to play with the throttle stick at various points and just check the acceleration of the entire turbine at various throttle settings, going from wherever it is, mid-throttle to max, etc. All right, guys, let's talk on some final remarks on this turbine, some of my final opinions, and some of my final thoughts on this thing. So overall, guys, I am absolutely impressed with the quality of this turbine. Everything about it is phenomenal. I don't find, honestly, any problems with this thing, and I have no issues putting this turbine in this Diamond aircraft. I think it's going to be an absolute monster for this aircraft. The weight of this thing is, it's extremely light for a 220 Newton engine. So at 110,000 RPM, so down thrusted by 5,000 RPM, we were still getting, I think, about 46 pounds of thrust. I'll throw a screenshot up here of that thrust figure on that last run. So that was absolutely phenomenal. At 115,000 RPM, we were getting just a hair under 50 pounds of thrust. So absolutely amazing. I will post all the specs of this engine and my findings personally down below. So the fuel figures and everything like that listed down below, my weight figures and everything as well. But guys, absolutely looking forward to putting this engine in this plane, and looking forward to some future opportunities with Swiwin turbines. So thank you, Swiwin Turbines, for reaching out to me. Thank you for organizing, getting this turbine to me, and thank you for allowing me to do some unboxing, test runs, and ultimately demo flights with this turbine. Looking forward to it. Unfortunately, the Kingtech that's in this plane is going to be coming out. Probably going to list it for sale. It's brand new, but we'll see what happens. Yeah, excited for this thing, guys. So if you do have any questions or comments, make sure you list them down below. You can also shoot me an email as well to thelightersideofrc.com. And the last thing, guys, I'm really excited to announce. I announced it on Facebook last weekend. There's a website now, thelightersideofrc.com. So if you have a minute, the link's down below in the description. And if you've watched this video this far, click on that link. Check out my website. It's definitely a work in progress, but there's some exciting things happening in the future. If you want to know more, shoot me an email, contact me, and I will share as much as I can with you. But there's some good things coming in the future for the lighter side of RC. Wink, wink. So that's it, guys. Thanks so much for tuning into this video. I appreciate all the support on the channel. I appreciate you guys watching my videos. If you've watched this far and you haven't done so already, hit that thumbs up button, hit the subscribe button down below. Don't forget to hit the bell so you get notified when I release new videos. Thanks, guys, and we will see you in the next video.